Welcome back to the Node Express PostgreSQL tutorial. We will use on the PG module only to access the PostgreSQL database, so it will be faster instead of using ORM such as Sequelize.js, which was introduced in our previous tutorial. But we need more effort to create a PostgreSQL table and write SQL in our Express application. This tutorial is divided into several steps. Step number 1. Set up PostgreSQL database and table. Step number 2. Create Express.js application. Step number 3. Create REST controller. Step number 4. Create a router. Step number 5. Run and test Node Express PostgreSQL using Postman. Let's get started with the main steps. Step number 1. Set up PostgreSQL database and tables. Before creating a Node Express application, first, we need to create a database and tables. We will create two tables with one-to-many relationship. To create a database, go to the PostgreSQL console from the terminal or CMD. Next, save these commands for creating a new user with a password, then give access for creating the database. After quit PSQL and then login again using the new user that was previously created. Now, save these commands to create a new database. Then give that new user privilege to the new database and then use the database. Create a sequence and table for products with these commands. Next, create a sequence and table for variants with these commands. Next, populate the initial data for the products table. Next, populate the initial data for the variants table. Quit PostgreSQL console. Now the database and table is ready to use in our Node Express application. Step number 2. Create Express.js application. Open your terminal or Node command line, then go to your projects folder. First, install Express Generator using this command. Next, create an Express.js app using this command. Next, go to the newly created projects folder, then install Node modules. You should see the folder structure like this. There's no view yet using the latest Express generator. We don't need it because we will create a RESTful API. Next, add the PG Promise, and Bluebird modules to this application. Open these projects with your IDE or text editor. Next, add a new JavaScript file at the root of project folder for the configurations with the name config.js. Fill that file with these configurations codes. As you can see, there is a PostgreSQL configurations that was previously created and an additional configurations to limit the reset risk. Step number 3. Create REST controller. We will put database queries and some logics for both tables in a controller file. So the list, retrieve, create, and an update will be done for both products and variants in the same queries, except the delete operations will use a separate query. Create a new folder and JavaScript file for a controller. Next, open and edit that file, then add these required modules and config. Create an asynchronous functions to get a list of products including an array of variants. As you can see, there is only a single query to get both related tables one-to-many because we are using PostgreSQL array-to-JSON function. So the query for variants set as JSON array fields for a products. Next, similar to getting a list of products, we will create a products by ID. The difference with getting the list, just the pgpromise functions use one instead of any function. Next, create the functions to save a table product and its variants. First, insert product data with ID as a returning value, then loop through the variance array to insert its variant. Next, create the functions to update both the table products and its variants by products ID. The update functions is a little tricky. The body of variants should use the variant ID to update and without ID to add a new variant. The variant ID that is not found in the body will be removed. Next, create a function to delete a product and its variants by ID. Next, create the functions to delete a variant by ID. Finally, register of those functions by the export statement. Step number 4. Create a router. To handle requests and responses of the REST API, we will use a router file. Create a new file inside the routes folder. Open that file, then add these lines of router functions. Those router functions are get, post, put, and delete methods. Each function calls the functions from the controller. Next, register this router file to the app.js. Next, modify the error response to show the error as the REST API response instead of an HTML page. Step number 5. Run and test Node Express PostgreSQL using Postman. Before testing this application using Postman, run this application first. Start Postman, then create a new request with method post, then the headers with content type application.json, and the URL is http localhost 3000 v1 API product. And the request body is raw.json. Then click the send button and the responses is like this. To get the products and variants, change the method to get and disable the body, then click the send button. And the response should be like this. To update the products and variants, change the method to put an URL to localhost 3000 v1 API products /1. and body payload like this. The response should be like this. To delete a product by ID, just change the method to delete. To delete a variant, to change the URL to API products variants variant ID. That is the Node Express PostgreSQL faster CRUD REST API. You can get the full source code and the article in the descriptions below. Thank you.